legend says that Ethereum was created because someone nerfed Vitalik's Warlock, right, on World of Warcraft, and that's why we have this new kind of internet. So I think like I think games on Web3 eventually are gonna be big. So Ethereum is about decentralized computing, right? Our industry is about decentralized computing. And it turns out that the decentralized part was very hard to achieve. And we spent all these years focusing on making the decentralized piece a reality. And we left the computing behind. So we end up with very decentralized but very constrained computer, right? Execution environment in which you have to rebuild everything, right? And that's a very hard environment to build a fun game on. So we have built some games, but let's be honest, like at least most that I played were not like that fun because they had this forced simplicity to it because they had to rewrite everything from scratch, right? And it's a funny example. Like there was a game, I think it was called Topology, which is quite interesting game back in the day, and it had this like planetary logic and so on, and they had to code the entire physics in Solidity, and I'm sure it took them like a long time to do it. Like imagine coding all the physics from scratch. And if you take like a game like Angry Birds, Angry Birds uses the same physics, right? When you like slingshot a bird, it uses the same like physics laws as the Topology game did. And I'm sure the Angry Birds developers didn't have to write those physics laws, They just imported a physics library that already existed on a normal Web2 software library. So what I'm trying to say is that the environment is so constrained that it makes it very hard for you to build cool games. So I think once you start to work on the computing part of the decentralized computing, you start to unlock the possibility of these new cool games that are actually fun to play. And then I think eventually we'll see a boom of Web3 games.
Welcome back to the podcast. Today we'll be talking about L2s, Ethereum, scaling, execution, and Felipe Argento from Cartesi here will tell us a bit more about it. It's so funny because I literally butchered your name. I practiced 2 times and I still mispronounced it.
Actually, that was a great pronunciation. Even better than the practice run, so all good.
Thanks, man. Thanks for making me feel good about myself. But tell me a bit more about yourself. You mentioned that your last name means silver, which is like really beautiful. But tell me about your background. How did you get into crypto? What did you do before that?
Sure, yeah. So I'm from Brazil, right? And I went to uni for computer engineering, which is like sort of a mix between computer science and electrical engineering. And towards the end of my time in college, I just stumbled upon crypto online on Reddit, I guess, and just got like really interested in it because like it was a mix of like game theory and computer science and economics and philosophy, and uh, like I got instantly hooked. And then I started a study group with some friends in college uh, that eventually turned into a company. Not Cartesi though, just another random company. And then one day I was working on this company that I had just started, and one of the other co-founders of Cartesi just called me. His name is Eric, and he was starting this beautiful project with 2 math professors of a math institute in Brazil. That it's like one of those like schools that is known for only hosting geniuses, and they were like teachers on that place. And then he called me like, "Yeah, I'm starting this project. Do you wanna come in?" I'm like, "No, guy, no, man. I have my own company. Like, why would I do that?" And then like as soon as I hanged up the phone, I kept thinking to myself like, "All right, like I'm here in college, with a couple other college students, and I have this guy. There's like a well-established entrepreneur with 2 geniuses researchers behind him, and I'm choosing my idiot college friends." That makes no sense. So I called him back, like, actually, like, let's talk about this. And then I joined Cartesi. Yeah.
I love this. So, what was your first impression of Eric? How did you fell about him?
And Eric is great because like you can instantly tell he's a very, very smart dude. Uh, but he also is like a very philosophical minded. So like he'll engage you in any conversation. You know, it's not like one of those guys that if you say something dumb to them, they'll just like brush you off. He'll actually try to understand you and like get to the bottom of your stupid idea, I guess. It's great, yeah. It's nice to listen to him talk. I recommend everyone to follow him on Twitter and read his writings.
But tell me more about how did you feel when you picked up the phone? Like a random guy calling you saying, "Hey, do you want to join this project?" Did you think it's a scam or did you actually trust him? Like, did you Google his name? What was that initial feeling?
Yeah, actually, so he found me through a guy that was like my boss at an internship that I had, and that guy recommended me. So like as soon as he's mentioned this guy's name, I knew that he was legit, you know. And then we just started talking, and the Cartesi idea is quite crazy, and at the time even more so. It was like very in the future, I guess. So I had a hard time like picturing like, all right, like how far away are we from this? And then he's explained to me, and like I saw the vision, and then I just got very excited.
And you mentioned that you're Brazilian and recently hackers stole 1 billion real, which is around $180 million, from the central bank by a simple bribing of an employee at a CMA software. So, how do you feel about it? Like, what's the sentiment within Brazil? Because I'm sure that you're very well connected within the Brazilian crypto community. You might know some legislators, or some of your friends might know legislators. Like, what's the insider perspective? Because I feel like we've read a lot of news articles how that happened. A lot of publications covered it, but how does it feel on the ground?
Yeah, that's a good question. So actually, I don't have much contact with the like the financial side of crypto too much, and especially in Brazil, uh, legislation here is uh, always very complex. Our central bank is actually quite tapped into crypto, so they have a lot of like projects studying and mapping out crypto. I think they even like finance some accelerators and stuff like that. But you know, like these kind of attacks, it just shows that our financial industry in general, like worldwide, is I guess lacking in the sense that like it was built for security, of course, but it is built in a way that it's not very good at surviving adversarial uh, permissionless access, right? That's one thing that I like a lot about blockchains and Ethereum specifically, is that like Ethereum is a network that runs 24/7, and anyone can access it and anyone can interact with it. So everything that you build on Ethereum is made has to be made to sustain any kind of like anyone can read the code and interact at any time as much as they like, right? So you build stuff in a very robust way. And I feel like sometimes this financial software uh, has like a blind side for stuff like permissioned access. You know, someone with a lot of power in a company can in a bank ha- can have accesses that can like mess up the system. I'm sure if you released the code base of all the banks in Brazil, a good percentage of them would get hacked on the next couple weeks. You know, uh, so in a way, it just points to the need to upgrade the backbone of the financial industry as well.
Yeah, I completely agree with you. Um, but I want to go back to Cortese and the project. And I assume that the name comes from like Cartesian philosophy by Rene Descartes. And it's very closely linked to mathematics. And as you said, like two of the co-founders are actually professors. Um, in mathematics. But tell me a bit more about the backgrounds and the name. Like, how did you guys come up with the idea? But also the logo, because the logo is like a penguin. So I really want to understand, like, how does this all link together into this one beautiful piece that you guys called Cartesi?
Sure. So yeah, the name comes from the cards. I was not yet part of the project when the name came about. Actually, the name was one of the first things that they had the idea for. I guess it comes from like Eric liking the philosopher and the other guys liking the mathematics of the cards. Uh, of course, you have like a when time goes, you can find retroactive explanations. So
Yeah,
like if you think of the Cartesian plan, you can think of like data availability and execution being like X and Y, or like a layer two, like adding a second dimension to the
that's so true. Yeah.
yeah, the L1 axis. You can find uh, you can find stories to justify the past as long as you like. But the penguin itself is a bit more concrete actually, because one of the cool things about Cartesi, so I'll talk more about it later, but Cartesi is basically an execution uh, environment, right? And it's a very powerful one. And one of the reasons why it's very powerful, it's because it allows you to build a Linux operating system uh, and make that totally compliant and secured by Ethereum itself. And the Linux, the logo of the Linux is a penguin. It's called Tux. So we know we are bringing the penguin to Web3. We're bringing the penguin to Ethereum, and that's why we have an exploratory penguin that sometimes runs around in our marketing stuff.
I love that. I love that. Um, I definitely want to talk a bit more about Cartesi, but essentially it's a L2 rollup, and you guys are aiming to scale Ethereum, mainly focusing on execution, and then you can have settlement DA on Avail, or you can do it on the L1, which I really like, and I think it was a feasible idea before Vitalik, this not just Vitalik, but the foundation decided to go crazy and have the L1 as a base rollup. So after he posted that he wants to implement Risk 5, and the price went down, and issues with block space, a lot of people moving to the L2, finally not occurring on L1, the entire picture. It feels like Ethereum is doubling down on increasing the throughput and execution on the L1, and they incentivize projects now to build on the L1. How do you feel about it, and how does it change your approach and roadmap as an L2? Not you particularly as a project, but I really want to hear your take on the broader industry.
Sure, yeah. So first of all, I'm very bullish on ZK-fying the L1. I think that's gonna improve a lot of things. It's gonna like improve decentralization by a lot. It's gonna improve security. You'll be able eventually, I guess, to verify the chain on like your phone, and that's all exciting. It also probably diminishes the price of interacting with the L1 because you can like increase scalability on L1, uh, and well remain like keep the validator set decentralized. So very bullish on that. When you talk about L2s, there are a few different reasons to have L2s, right? And I agree some of them are less compelling now with this with this change on the L1 roadmap. I think first, for instance, shared EVM optimistic rollups, they kind of like lose their sense of being. But Cortez is focusing on app chain rollups, right? And with a twist, which is this different execution environment. And and there's no world in which every application runs on L1, right? The internet cannot run in a single server. You have to split that attention. You have to split computational power. You have to have different realms in which people can validate one thing and not validate the other thing. So in the case of Cartesi, we're building for a world in which you can spin up a very complex, large application, and you can have only people that care about that application verifying it, and that application has access to an execution environment that is much more similar to the normal executing environment that you use for Web2. So you use it for, which is Linux, right? But you use it for like every internet server, and you use it for like space applications and retail applications and e-commerce applications and games everything else. But it's an execution environment, Cartesi, that requires a very high level of computation. You need a lot of computing power to run it. So it's not compatible with ZK. We even use ZK a little bit, but like there's no foreseeable future, uh, at least like middle to the short to the medium term, that you can prove a Cartesi application using ZK. ZK is way too expensive for that still. So it's a world in which like uh, some things lose their purpose because they got surpassed by ZK, but things that require more complex, more expensive computations, they're still far out of reach from ZK.
And you touched upon ZK. That's very interesting because Cortese is an optimistic rollup. Tell me about your prediction, and are you worried that everyone is doubling down on ZK? We have Succinct and a few other L2s that are tapping into the ZK technology. It's very challenging to predict, but if you're talking to the people within the ZK environment, they would say, "Oh, we'll have everything on ZK L2s within 5 years." And then people on the optimistic side will be like, "No, that's no way. Computation is really high. It's going to be expensive." I guess you're on the second side, but like from a very objective and educated opinion, what do you think? How do you think this will play out? Do you think that in the future, like next 10 years, you might need to switch to ZK? Do you think the people now that are building on ZK um rollups will have some benefits that you won't have in the next 10 years?
Yeah, for sure. Like ZK, I'm a big fan of ZK. ZK has some very cool properties. The instant settlement is a very cool property that for sure helps a lot. Uh, and I think like there's no silver bullet here, right? I think it depends a lot on the application that you're running, uh, on the complexity that you're aiming to enable. Uh, so it's hard, of course. Like if it's in 10 years, ZK like proving a computation costs very very little, just like costs the same as the application as running the application itself. Of course, like we would make the switch to ZK, but as of now and in the foreseeable future, uh, like ZK costs much more than just running the computation normally, right? So you lose throughput and you lose it's very costly. If you're running something like a financial ledger or like a Ethereum, in which the applications are by design quite simple and it's a very constrained environment, then ZK is the right tool for that, right? Because you can, and it's still quite expensive if you go to ethproofs .org, if I'm not mistaken. You can see the cost of proving transactions and blocks on ZK. And if you calculate how much it costs to prove Ethereum in an entire year, it's quite a lot of money, which is totally justifiable to Ethereum, right? Because of the level of TVL and financial activity that goes on Ethereum. So it's actually the right choice for Ethereum. And it's a very cool project, by the way. Justin Greg is championing that. I recommend everyone check it out. But once you go to like app chains and this world in which you can have like very complex applications that cover an entire vertical, then the cost doesn't justify itself anymore, right? Or the throughput doesn't justify itself anymore. So that's the world that we're aiming for at Cartesi.
Okay. And can you tell me a bit more about app chains and the benefit of them? And also, what's the alternative? Because you mentioned them a few times. And it's like app chains, the alternative, and I guess what's the benefit of building dApps on certain app chains?
Sure. So there are two approaches that you can have here, right? You can have a shared chain. Sometimes they call it a general purpose chain, which is just like Ethereum L1 or I don't know, Optimism, mainnet. It's like every dApp, every application is sharing the same layer. so they can all talk to each other instantly. But every time an application becomes popular, all the other applications pay an increased fee on gas and operations and so on. So they all share the same layer and they all share the same attention from the validators, computationally wise. App chain is a role in which each application run on their own chain, right? So instead of having Uniswap sharing the main chain with Aave, have Uniswap running on its own chain. And that is interesting for a variety of reasons. First, the first reason is that the demand on that chain is entirely dedicated to Uniswap, right? So Uniswap doesn't suffer price fluctuations because another app is getting popular. And that's good both for Uniswap, but also for the other apps, right? That sometimes get gentrified out of L1 because everyone is using like Uniswap. The other thing that it allows is a lot more flexibility, right? So now Uniswap can uh, maybe define different economics for the chain that they're running on. So maybe they can, I don't know, like if there's someone market making, they can give them a discount on the gas price of the transaction, or they can charge more for another operation that is not pro-social in the Uniswap context. So you got a lot of flexibility. You got a lot more computational scalability because now the entire computation of the chain is dedicated to your application. And then you lose on composability, right? Because the app chains, they run on top of Ethereum and they have to communicate to Ethereum what has happened. And this time between them communicating and the other applications finding out, there's a like a delay in composability, which I think is totally justifiable, but that's the trade-off.
And can you tell me what industries do you think are very suitable for this DApp chain future, and what industries are very good for the shared L1?
Sure, that's a very good question. I think, like in general, industries that require a lot of composability. So if you take Aave, for instance, uh, Aave is like you get a loan and you use it instantly on some other protocol, and like these financial levels, they require like instant communication and instant transfer of assets. So the world of simple, and I'm saying simple not in a derogatory way, but simple in the sense of like the amount of computation that you need, or simple DeFi is well suited for these shared chains. If you start to do something more complex, say you want to run an entire exchange that has like perpetuals and futures, and you can borrow and you can stake and so on, and that all happens inside the same application, then you start to need to have an app chain, because the money, once it goes in the application, it stays in the application until it comes out, and that's okay, to have a little delay when money comes out. You can have things like liquidity providers, someone fronting you the money, like things work out. Another good example for app chains are games, right? There's no reason that a game needs to, like you're playing World of Warcraft and you have like this cool like shiny armor that you got. You don't need to compose that shiny armor with Aave. You can just like you put the money in the game and you spend, you generate assets, and then when you want to get out of the game, you just get out of the game. But once you're playing the game, everything that you have and all the interactions are inside the game. You don't need to leak information out that often. So I think this is a good example for anything that grows in complexity is a good example for app chains, in my opinion.
Yeah, gaming is something that I was expected you to say, so I that's why I smiled, got very enthusiastic about it. What's your take on Web3 gaming? Do you think that it will come back? It feels like last cycle it was meant to be one of the biggest narratives, and then the cycle before that, people also got excited about Web3 gaming. I haven't heard as much talk about Web3 gaming this cycle, but what's your take? Do you think they will see some triple A games? Normally, people say that it takes up to 5 years to develop a triple A game, and then a few years for it to become popular. So it's a comparatively long process. Yeah. How do you feel about it?
So Ethereum, the legend says that Ethereum was created because someone nerfed Vitalik's Warlock, right, on World of Warcraft, and that's why we have this new kind of internet. Uh, so I think like I think games on Web3 eventually are gonna be big. Uh, so Ethereum is about decentralized computing, right? Our industry is about decentralized computing. And turns out that the decentralized part was very hard to achieve. And we spent all these years focusing on making the decentralized piece a reality. And we left the computing behind. So we end up with a very decentralized but very constrained computer, right? Execution environment in which you have to rebuild everything, right? And that's a very hard environment to build a fun game on. So we have built some games, but let's be honest, like at least most that I played were not like that fun because they had this forced simplicity to it because they had to rewrite everything from scratch, right? And it's a funny example. Like there was a game, I think it was called Topology, which is quite interesting game back in the day, and it had this like planetary logic and so on, and they had to code the entire physics in Solidity, and I'm sure it took them like a long time to do it. Like imagine coding all the physics from scratch. And if you take like a game like Angry Birds, Angry Birds uses the same physics, right? When you like slingshot a bird, it uses the same like physics laws as the Topology game did. And I'm sure the Angry Birds developers didn't have to write those physics laws. They just imported a physics library that already existed on a normal Web2 software library, uh, one of the many open source libraries out there. So what I'm trying to say is that the environment is so constrained that it makes it very hard for you to build cool games. So I think once you start to work on the computing part of the decentralized computing, you start to unlock the possibility of these new cool games that are actually fun to play. And then I think eventually we'll see a boom of Web3 games. But let me say this: we have one of the coolest applications in Cartesi, built on Cartesi. It's called Rives, Rives. You can find them on Twitter on X, the Rives.io, also the website. It's like a world arcade game that you can actually code your own card states and submit to the application, and then you can play like all these awesome games on chain, fully decentralized, fully verifiable on Ethereum. And you can play Doom, you can play Snake, you can play like Pac-Man and some like custom made games. It's quite cool.
Okay, I'll definitely check them out. This sounds interesting. I listened to another interview with you, and you said that the aim of Cortesia is to increase the complexity of dApps on Ethereum. And there are two main things that have to be solved to be able to achieve that: computational scalability and solve the execution environment. Can you please double down on these two main issues and why they're so important for us to solve before we increase the complexity of dApps?
Sure. So when I say increase the complexity, I mean increase the enabled complexity, right? Like how complex you can make your apps. I don't want to just get a simple app and make it complex just for making it complex. But let me go go into these two pieces, right? The first one is computational scalability. So it's basically the amount of computation that a dApp is allowed to make. If you code something on Ethereum, on Solidity, the base layer L1, right? You have to be very mindful of every single little computation that your smart contract is doing, right? Because everything costs gas. So if you run a complex game, very soon a single interaction on that game is costing uh dollars, like actual like significant amount of dollars, right? Uh, so you gentrify those complex applications out of the Ethereum L1. You gentrify those games out of Ethereum L1 simply because they take too much computation to be enabled. Uh, Once you start to scale computation, and that means decreasing the price per interaction, you start to be able to run things that actually take more interactions and take more computation, right? So you can do like derivatives if you go on finance lenses. You can do like derivatives calculations, complex financial instruments that take a lot of like uh, math behind it. So that's a piece about increasing computation, right? allow us to make apps that actually do more math, do more instructions, more cycles per interaction. That's a very important piece. Uh, for instance, just to hammer down on that, Uniswap is an automatic market making exchange, right? So you have to lock your money there, so your money can serve as liquidity for actors coming in and out. Uh, well, that's less efficient than order book exchanges, right? That is the norm on Web2. And that's less efficient because one of the reasons is that you have to have your money locked in there. And why did Uniswap choose to do that? Well, Uniswap is forced to do that because of the limitations on computational scalability on the chain, right? And also throughput capability, right? So the cost of sending transactions as well. Uh, so Uniswap basically has to take unoptimized choices because of the constraints in the L1. Once you increase computational scalability, once you increase transaction throughput, then you can start to make, say, like you can have an order book exchange on chain, and then you lose this cost of having to have your money locked in an application to provide market making services. So that's a piece of computational scalability. But once you have that, you still have a second problem, which is an expressivity problem, right? Which is similar to what I was talking about when I was talking about Angry Birds. Ethereum, the execution environment on Ethereum and on most of other L tools, they are very different than normal execution environments that you use on, well, your normal computer day-to-day life, right? They are like the EVM or the I don't know, like Cairo machine or the Solana virtual machine. Uh, they're quite different, and that means that there's not a lot of code that has been written for it yet, right? If you take something like RISC-V or ARM, or like, you have decades of open source tooling that is compatible with it. You don't have to rewrite everything. You can, on the case of Cartesi, since we are bridging this Web2 environment to Web3, and we put Linux, right? We have an operating system. Then you can actually like run all the software libraries that are available for Web2. You can run it on Web3. So instead of having to rewrite from scratch your physics law, you are able to just import the physics law from someone that built it for like a Web2 application back in, I don't know, like 2005. So the expressivity is what allows you to increase the productivity of your work, right? So if you're building an application, if you have an expressive execution environment, you're able to focus on the new piece of your application, right? You don't have to spend time trying to recode what has already been coded millions of times before, right? Like logarithms, functions, or gravity laws and stuff like that. So this piece unlocks the what you can do as a developer. So that's quite cool.
I really enjoy this, and I want to double down on Cartesi and what you guys do. But for the sake of the listeners and viewers, I think we need to first discuss the difference between modular and monolithic blockchains. And then from there, we're going to explain how Cartesi fits within this modular stack and why the modular stack is superior to the monolithic. I think you already touched upon the difference, but can you just quickly explain the difference between modular and monolithic blockchains, and why do you believe modular blockchains are superior?
Sure, yeah. So that's a little bit of a controversial topic because the definitions of modular and monolithic, they change a lot and depending on who you're talking to. Some people see it as like as a branding mechanisms. So other people see it like as a way to architecture your code. But I'll first define it with like I think a commonly accepted definition, and then I'll talk a little bit about it. Uh, so modular blockchain is when you look at the blockchain at the blockchain stack and you divide it into the Lego pieces that are needed to make it work, right? So if you want to have like a decentralized application, Then you need a few components, right? You need a consensus layer. So you need to have a way to agree on the overall state of the application. Then you need a data availability layer, which is a way to, well, where you can make sure that data was published, so everyone can agree on what data is available to that application. Then you need an execution layer, which is like where people agree on what was executed and what was the result of executing that part. And then you have the settlement layer, and some people have other modules that they like to talk about. But let's think about these ones, right? You have the consensus piece, the data availability piece, the execution piece, and the settlement piece. A monolithic layer is a layer in which all those functions are performed by the same stack, right? So it's the same chain that does all those functions. A modular chain is when you start to delegate some of those functions to another player, in a sense, to another layer. So, for instance, when you have Ethereum as a L1 and you're running an L2 on top, that is a modular stack. You're running the execution piece of it on a different layer. You can even go beyond that, and you can like choose a DA layer, such as like EigenDA or Celestia Veil and whatnot. And then you have your data on that layer, and then you have consensus on Ethereum, execution on an L2, and so on. You can have a sequencer like Espresso, and anyway, like the combinations are crazy. Once you have these Lego pieces defined, you can just like stack them depending on your needs, right? And I think just by this explanation, I think you can see why I think this modular way of looking at architecture is better, right? Uh, One of the basic reasons is because you can choose the Lego pieces depending on the needs of your application. Right? So if you're just running a simple application that requires a lot of composability and it's a very financially heavy application, you can charge a large price for transactions. Then you can just run it on Ethereum L1, just a monolithic Ethereum, Ethereum for DA, Ethereum for consensus, Ethereum for execution, and Ethereum for settlement. If you're running a complex application that needs more computing power and that needs a different execution environment, you can run on a Cartesi L2. So you use Ethereum for DA, and you use Cartesi for execution. So you can pick and choose. Another interesting thing about this is that you have teams that focus to understand very well and solve a very specific problem, right? So instead of having like a brilliant researcher have to think about consensus, data availability, execution all at the same time, you actually compartmentalize those things. And you're like, all right, now you're only gonna think about execution. So build the best execution piece that you can build. And that's what we're doing in Cartesi, right? So we're focusing, like laser focused on the execution piece of the puzzle. So all our brilliant people or all our researchers are like focusing on how to make the best execution environment possible.
And as a developer, once I outsource the DA, the settlement, to, as you mentioned, like Ethereum or Aave or Celestia, and I implement the execution on Cartesi, can you just tell me what's the difference between doing it on Cartesi than doing it on Base or any other L2 that has a higher TVL and probably like more developers? What's the benefits of doing it on Cartesi?
Sure. Yeah. So uh, all these altrues that you mentioned, they are in a sense a copy of Ethereum running on a different layer, but they all run the EVM, which is the Ethereum virtual machine, and you code in Solidity, like you have the same constraints as you have on L1, though the price of interacting is cheaper, right? But execution is still constrained. You cannot like use whatever programming language that you want. You cannot not use whatever open source software is available out there for you to use. In Cartesi, the execution environment is the Cartesi machine, which, and now it gets a little bit technical, but it's a RISC-V based emulator, a deterministic emulator that is able to boot up a Linux operating system, but it could also boot up other operating systems such as Cell 4 or other things, right? But this execution environment that you're using at Cartesi, this Cartesi machine, is actually compatible with the Web2 execution environments that you have out there, which I think have proven themselves to be the best place for you to build an application, right? So when you build a application for the traditional web, you're not like choosing different operating systems depending on the application that you want to build, right? If you're gonna build a, I don't know, like a website, you're gonna build it on a on a the same machine that you would build if you're gonna build a application for a supermarket. So so we had this Cartesi machine, and this Cartesi machine allows you to build applications not only on Rust, but also on Python and Go and whatever programming language that you have, and not only using the syntax of those programming languages, but you can also import libraries and packages and so on. So, for instance, you could have a Web3 application that imports TensorFlow and PyTorch and does a little like uh, something fun of machine learning, you know. Uh, so, in a way, if you build on Cartesi and not on Base, you'll get access to this full suite of already built code and tooling that we have on your normal computing life that is usually not available to you on Web3. But you still retain the security guarantees of Ethereum, right? Because we have a fraud proof, and you can prove everything that happens inside a Cartesian machine. You can prove that it happened to Ethereum by a very small fraction of the price of the calculation. So it's still everything is compliant, right? So that's why we call it a bridge. It's actually a very securely made bridge between the real world of software to Ethereum.
Okay, so it might be a stupid question because I'm not a developer. The way I envision it is that if I'm a Web2 developer coding on Python, C++, and I want to tap into the blockchain environment, I can do it through Cortese without knowing Solidity.
Yes.
And I don't really need to learn a new coding language. I can just code with my current coding language, use the current database, but have the benefits of blockchain.
Yes, you can use your normal app and deploy it on a decentralized computer such as Ethereum, and it's gonna run with the properties of Ethereum base layer. Of course, like if you're gonna make a blockchain application, then you probably need to know a little bit about blockchain. At least you need to know why it makes sense to run your application on the blockchain. But you don't have to code your application in Solidity. You don't have to do that. You can use your C++ language. You can use whatever you want. Yeah, that's a very good explanation.
Okay, okay. And that's really interesting because you enable a new group of people to just tap um into that new environment. Can you tell me a bit more about the type of dApps that have been developed on top of Cortese, or teams that would reach out to you and be like, hey, this sounds amazing. I want to build on top of you because I want to tap into the security of blockchain and decentralization.
Sure. Yeah. So we have a lot of like as we were talking about games that were interested in building cartels just because well games are usually the first movers of innovation, right? And cartels you can like use the gaming libraries and so on that they love to use. So we have some cool games that were built in Cartesi. Vibes is one of them, as I said. Uh, but we've had Dome and we've had like tower defense and so on. So that's cool. We also have had another very we have a chess tournament game that's built on Cartesi as well, which is kind of cool. They use the ELO rating calculation that FIDE uses, so you can have all of that on chain. That's fun to play with.
So
Well,
wait, sorry to interrupt. What's the benefit of having this game on chain? I guess because I play chess. Let's say I play on chess.com and whatever my ranking is like 1900. So now I want to start playing on this new app. I guess there will be fewer players. So even if I have a comparatively high ranking, it probably won't be the accurate one, just
yeah,
mainly because of the number of people. Um, but also, what's the benefit of having it on chain? Like, why should I move on chain rather than keep playing it on my chess.com?
Yeah, well, that's a good question. The game was built more to like showcase the value and what you can do on Cartesi. So it's like in a way a very interesting technical showcase because it's not something that you could do on Solidity normally. Uh, as far as like the benefits of having chess on chain, I guess it would you could justify it if you didn't believe like the chess.com integrity. You know, if you think that they're meddling with the elos, or if you want to have like a betting layer on top of chess in which you can bet your friends, or like you can, I don't know, like automatically bet on a player on a championship, on a tournament, or buy a piece of the player. I don't know. You can like imagine like financial layers on top of the normal chess game. But I mean, the chess example, it's easier to think of it if it was a poker platform, right? Imagine if you had a poker on chain. Then the poker, like I'd say that the poker platform has a little bit more incentive to to mess up with your cards a little bit, or to I don't know, benefit one of the sponsored players. Uh,
Yeah, there were like a lot of casinos on chain because of it. People were like, how the hell am I supposed to trust that I'm actually winning and it's not arbitrary and it's pure luck? Which is like really interesting. They feel like they
exactly.
more 7 months ago and now they died out. I haven't heard much about casinos anymore, like on chain casinos. People are probably still building them, but
Yeah,
they're not as
probably.
popular.
Yeah, but there also because of this problem of computing that we were discussing. What you can actually do on a Web3 casino right now is not very exciting, you know. Uh, but if you start to, and I don't know if that's something that you want to do, just like get a new generation addicted to casinos. But as you grow your computing power, then that's something that you can create better and more fun casinos, you know.
Yeah. And earlier on, you were talking about Linux as a coding language, yet tapping into the decentralization of blockchain. And I was thinking, what are the trade-offs? As I mentioned, I'm not a developer.
Yeah, yeah.
I vibe code, I've tried, but can you outline, because I was going through your white paper, try to like understand the project, but I honestly just can't identify the problems with it. Can you help me understand what could be a potential problem? Like, how the hell no one else thought of it before you guys? And obviously, you're extremely smart. But at the same time, what's the trade off?
Yeah, yeah, that's a good question. Uh, well, so yeah, Linux as the operating system, right? So in a sense, bringing Linux as the execution environment to the blockchain. That was a very novel idea at the time. The mechanism that we used to do it is very similar to what TrueBit was doing back in the day. It's just similar to what Arbitrum is doing. So this fraud proof uh, kind of game. Though we have published papers in scientific research magazines showing a better way to do fraud proofs. It's similar to the mechanism that was used before. So the reason why no one has done it before, I think people were trying to solve more immediate problems. The problem the Cartesi started to solve back in 2018 was a problem that was a few steps in the future, right? You had much more basic problems to solve in which and people were focusing on those problems, such as like transaction throughput, stuff like that. And as we were talking about, extending Linux to blockchain applications only makes sense if you start to have more complex applications and more intricate applications. Uh, and those were not even like you couldn't even imagine them back then. So I think that's why no one was doing it back then. Also, it's a very hard thing to do. So don't take me wrong. Like we have very smart researchers and developers. Some of them who are specialists in execution environments on Web2. So they brought their expertise to Cartesi. Uh, but nowadays, we actually are starting to see competitors, quote unquote, pop up. They're trying to do the same thing, right? So back in 2018, we didn't have a concept of app chains or a concept of alt VMs. I don't know if you heard that before, but it refers to alternative VMs. nowadays, if you search alt VMs online, you'll see a lot of other projects trying uh, to create Watson-based VMs or other RISC-V based VMs and so on. So it's now something that people have recognized that is super valuable, and they're starting to do it. But we have a 5-year advantage on that, right? Because the engineering challenges are quite significant, uh, and we've been working on that problem for a long time. So I think it was just like one of our geniuses, mathematicians. He was able to foresee the future as it happens sometimes, and then we started building back then for the future that we predicted would be coming up now. Sorry, and the trade-off, yeah. So the trade-off is exactly this, right? Back then, it was something that was, uh, you couldn't imagine it because there were so many problems to be fixed before this was even possible. Uh, so like the complexity is a trade-off, I guess.
Okay, okay. But is there any technical trade-off? As in, if I now decide to become a developer and I go straight for Solidity and learn Solidity, would I have a better execution environment, like more expressive? I don't think it'll be more expressive, but because obviously Linux has more options, but what will be the benefit of learning Solidity now? Because if you could offer Linux to everyone, like why are developers even learning Solidity?
Yeah, that's a. So first of all, we still have to get known by everyone, right? So we hope that in the future, more and more people are gonna be building.
After this interview,
Yeah, that's it.
you
Solved. Yeah.
that's it.
So I've.
You don't need to do any more.
I'm not even gonna answer your question then, because soon everyone's gonna be building on Cartesi. No, that there's a trade-off of like, well, Cartesi is very different than most other uh, blockchain projects. So if you build your code on Solidity, then you can like already find a tutorial of, well, how to build an app, Web3 app, and that's gonna be in Solidity. And if you build that, you can launch your app on Ethereum, and you can launch your app on one of the many like Ethereum uh, copycats or L2s that use Solidity, right? So in a sense, it's familiar tooling for Web3 people. So this is a funny like it's a funny thing to think about when you think about Cartesi, because we're talking about this expressivity and the Web2 tooling and the decades of open source tooling and open source code that you can bridge through Cartesi. Uh, but the Web3 people know another kind of tooling. They know like the tooling for Solidity, like Etherscan and Remix and Hard Hat and so on. So that tooling we don't use. We use another set of much more mature tooling, but we don't use the Solidity made tooling, right? So so I think it's a matter of educating and showing to Web3 people that look, this is possible now. This wasn't possible 1 year ago, but it's possible now. So come try it out, and you'll see how much fun you'll have and how much like how much more you can do when you're building your app. So,
And you mentioned Etherscanner. So how can people check whether a transaction has been settled uh, on Cartesi if it's not Etherscanner? Like you've developed your own um, blockchain verifier?
yeah, so like of course, like transactions that come to Cartesi, they still pass through Ethereum. So you can look at Etherscan to know if your transaction was accepted in the Ethereum base layer. But to understand the effect of that transaction on the Cartesi application that you're interacting with, then you have to look at the
Oh,
Cartesi scan, which is
yeah, yeah,
the
yeah.
Cartesi version of the Etherscan. But we're having to rebuild all those to build all those tools from scratch. So it takes a while for everything to be ready and usable for people to understand what's going on. And Cartesi itself, like it's a little bit complex to understand why the security assumptions hold and the trust assumptions hold. So there's a time in educating the community on like why is this safe? Why is this possible? First of all, because when you say like, all right, you can like run a Linux execution environment on the blockchain and you get Ethereum security. people are usually very skeptic about it, right? Because well, it's first of all, it sounds too good to be true. So you have to show them show them the code, but also explain to them why it works. Luckily, like nowadays, we have teams like L2Beat who do a very good job at showing everyone the trust assumptions and the security assumptions, that they review the code and review the algorithms. So they're helping everyone to understand the landscape of L2s. By the way, by far one of the best teams in Web3, L2Beat. I'm a big fan of them. So I hope that they'll help us explain Cartesi to people and why Cartesi is very, very amazing.
Where do you guys rank on L2 beat? I haven't actually checked. I'm desperately trying to go through it now.
Yeah, so actually, if you look, Eltwit recently went into a recategorization thing, which is like they got all old tools that, and they gave them like a deadline for them to have a functioning proof system. And
Yeah.
Cartesi is one of the very few projects that were able to do it in time. So now, if you go to the stage 2 tab of L2Bit, you'll find Honeypot, and Honeypot is the first instantiation of a Cartesi rollup on stage 2. So basically, launched the Cartesi chain. We put some money in there. This was very recent, by the way. It happened like last month. And
Oh
then
wow.
we put some money in there and say like, all right, come try to break this. If you break it, the money is yours. If you break the proof system, the money is yours. And the idea is to slowly increase the amount of money there. So you create like a sort of a financial benchmark to show the security and correctness of a Cartesi app chain, right? So
Oh wow.
if you go there on L2Bit on the rollup section, you'll find us on stage 2. We're very proud of that.
No, that's super cool. Wow, I like it. I want to bring you back to what you said earlier on about Ethereum and their fraud proofs, and you writing
Mm.
academic papers on how fraud proofs could be implemented in a better way. Can you just explain the Ethereum sorry, the Arbitrum. Did I say Ethereum? I
Yeah,
meant
you said it too,
Arbitrum.
but yeah, yeah.
Sorry, I
Yeah.
meant Arbitrum. Arbitrum fraud proofs, and then what's the alternative that you provide?
Sure, yeah. So early fraud-proof systems, they all had the same problem, which was it's called a delay attack problem, right? So the idea is that like when you're playing a fraud-proof games, and I'll try to keep this high level because I know many of the listeners won't be developers or not even developers, deep researchers of fraud-proof. But the fraud proof is basically you being able to play a game on chain to prove that someone else is lying about the state of an application, right? So we have different people uh, claiming that the state of application is something, and then you have them fight each other to see like who is lying and who's telling the truth. The problem of early versions of fraud proofs uh, was that if you had like millions of people defending different states of the application, to have like millions of people lying, maliciously lying about the state of a application, this game could last for like months. So like spend months without knowing what is the state of the application. And even worse than that is that if you have malicious actors with enough money, they can create enough fake states or enough lies that the honest person just runs out of money in the middle of the game. Like they have no more money to keep playing the game, and the malicious actors win by something called resource exhaustion. So it exhausted all the resources. Basically, like you ran out of money to pay your lawyer, and then the person suing you incorrectly wins the case by default because you have no more lawyer. Uh, and then as an industry, we're trying to solve this problem, right? And then we'll launch actually two papers on that. One is called PRT, and the other is called Dave. Uh, and Dave was presented on that con, by the way. So it's like a research paper explaining how to improve on this delay attack. So it's a different way to structure this game so that the honest person has a logarithmic advantage over the dishonest people, meaning that like effort added by the dishonest person requires a very small effort on the honest person to fight off. And the idea is that Dave shows an algorithm that, like, even if Japan, you get the GDP of Japan, and the GDP of Japan tries to attack your application, you with like a very little money can defend against Japan. So that's quite cool. Arbitrum has an alternative fraud-proof algorithm as well that was launched a little bit later than ours. It's called Bold, and it does have some interesting properties, and you can probably find some papers online comparing uh, both approaches. The problem that I see with Bold, and it's a problem that is especially critical for app chains, is that the bond that you need to put on for Bold to defend a system using Bold on Arbitrum is 3.6 thousand liters. So that's a lot of money to put up front. And with that money, you can defend the chain against a very big number of attackers in a limited amount of time. On Dave, which is our version of this fraud-proof game, I think the ether that you need to put on in advance is 1 ether. So of course, for app chains, it's much better to put 1 ether than to put 3.6 thousand ether, right? Because not every application will have that amount of funds disposable to protect itself.
Thanks. That was a really good explanation. I have a few more questions about it, and I love the discussion of fraud proofs, but I want to learn a bit more about the roadmap projects they're building on top of Cartesi, and what are you hoping to achieve in Q4, I would say, and then Q1, I guess the next 6 months, 6 to 8 months.
Yeah, so we have very recently put on the honeypot on stage 2, as we were talking about on Ultrabit. What we're working on now is to making that even more general. So everyone that creates an application on Cartesi can just instantly launch their application as a stage 2. So we'll have like a stage 2 rollup factory, right? To be comfortable at doing that, like to let other people launch applications using Cartesi of their money, we still have to go through a few more rounds of testing the current code base, because the algorithm is proven mathematically, right? So we're not worried about that. But the implementation of the algorithm is something that you have to like always uh, double check, triple check. So we are working on increasing the maturity of that code base uh, to allow other people to just launch stage 2 instantly. Then we have some builders that are experimenting with the tech and creating some cool applications. Uh, and in Q4, well, what I hope for Cartez is that when the next Robinhood comes to build on Web3, uh, they build on Cartez. At least a percentage of all the other Web2 companies that will eventually figure out that they need something in Web3. Some of them will choose Cartesi. So that's what I want to get. That's a point that I want to get to.
I love this. Thank you so much for your time. It was such a pleasure learning more about your project and the state of L2s in general.
Thank you, man. It was a very pleasant conversation.